Warm greetings. Welcome for online video session. Myself Jagadisha, an Associate Professor, Department of Computer Science and Engineering, Canara Engineering College. So we continue our online session on software engineering. So next, that is in the module 5, we see the project scheduling. Project scheduling is the process of deciding how the work in a project will be organized as a separate task, and when and how this task will be executed. Project scheduling is a process of deciding how work in a project will be organized, how actually the work is organized in the project. That is the scheduling. You estimate the calendar time needed to complete each task, the effort required, and who will work on the tasks that have been identified. So in the project scheduling, you should give the somehow like a calendar of that is how our calendar of event, VTU calendar of event or college calendar of event, when the internals has to be conducted, when the that is practical exams, practical internals, etc. The same way during the project scheduling, overall have to involve in the project, and what are the models or components has to be completed by each team is been identified. You also have to estimate the resources needed to complete each task, such as disk space required on a server, the time required on a specialized hardware, such as simulators and water. The travel budget will be. So, during the project scheduling, you should also analyze what are the resources is needed to complete the task, and whether the disk space is enough for the completion of the project in the server, and what time is required, and what are the hardware and simulators, and even if you want to go for anywhere for the understanding of the there is technology, then travel, you have to travel. For that also the budget has to be decided. So all those things will be analyzed in the project scheduling. Project scheduling activities, it splits the project into the task and estimates the time and resources required to complete each task. So resources, it may be a manpower, or maybe any of application, or maybe a technology, maybe a hardware, etc. It can be anything. Organizing tasks concurrently to make a optimal use of the workforces. So to make use of the manpower or any of the resources efficiently, the project scheduling is a necessity. Minimize the task dependency to avoid a delay caused by one task waiting for another to complete. So this is something like if any one person who is expertise has to be required in another task, so you should avoid the dependency. So such a way that you should plan the schedule for the project development. Dependent on project manager intuition and experiences. So project manager should always be an experienced candidate, and he has to put an experienced candidate during the development of a project. So these are the project scheduling activities. Milestone and deliverables. Milestones are the points in the schedule against which you can assess the progress. For example, the handover the system for testing. Deliverables are work products that are delivered to the customer. Example, a requirement document for the system. So project scheduling process, you can see here, identify the activities. After identify the dependency, estimate the resources for the activities, allocate the people to activity, create the project charts. So when you create a project charts, if you require any of the resources for the particular project, then once again you estimate the resources for the activities, then allocate the people for the particular activity. So after that, then design a bar chart for describing the project schedule. So this is the project scheduling process, and it's also very important question in the examination also. So identifying the activities, identifying the dependency, estimate the resources, allocate the people, then create a project chart. So whenever if you require any resources, once again go back to the estimate resources, then allocate the resources, then people, then describe the bar chart. So scheduling problems. What are the problems you come across when you analyze scheduling the project? Estimating the difficulty of problems and hence cost of developing a solution is hard. Estimating the difficulty of problems and hence the cost of developing a solution is hard. So we cannot come across any problem that come across while developing. So at that time you may come across, you have to spend a lot of capital for that to solve the problem, to find a solution. So that is a hard. Productivity is not proportional to the number of people working on a task. It's not that if you have a number of people on that particular task, you won't get a high productivity. You should have a skilled person to solve the problem. Adding people to a late project makes it is later because of communication overheads. So, if for example, if some person is involved, around 5% involved for developing a project, where they don't come across with a solution, then you may had 1 or 2% for the execution of the project. Or at that time, there is due to some late that is a involvement in the team, there will be a communication gap. Then you won't come across the result. So there is a problem. So that is another scheduling in the problem. The unexpected always happens. Always allow the contingency in planning. So these are the there is a scheduling problem you come across during the project scheduling. And schedule representation, that is graphical notations are normally used to illustrate the project schedule, and this shows that is project that is graphical notation shows the project breakdown into the tasks should not be too small. They should take about a week or a two. Bar chart are the most commonly used representation for project schedules. They show the schedule has activities or resources against the time. So you can see the one example. These are the given number of tasks is involved in the project, and effort person per that is day. That is effort of the person. That is to complete a task T1. It requires a 15 that is person per day, and duration it takes 10 days to complete the task. And task T2 it requires 8% per day, and it takes 15 days to complete the task. T3 20 and 15, and dependency T1 that is required that is milestone T3 required T1. Till then T3 cannot work work. So once T1 completed, then only it can start working the T3. So like that you can see the T5 to start his work, T2 and T4 has to be get completed, and T6 it depends on T1 and T2. So it's like that T12 depends on T10 and T11. So there are milestone or of 8 milestone. Each milestone dependent on that corresponding task. So milestone 3 it depends on the task of T2 and T4. Like that T1 and T2 there is a milestone of M4. That is a milestone 4. So this is what the one example they have given. And we will just try to draw the bar chart. And bar chart can also be called as a Gantt chart. So this is activity bar chart, and we can call it this as a Gantt chart also, because the person who found this is by the name Gantt. So they given the Gantt chart itself, the name. And you can see here the weeks, number of weeks is being represented in the x-axis. In the y-axis they have assigned the task. So this is what the task starting of the that is starting. So task T1, T2 and T4, it is it doesn't have any dependency. You can see here task T1 and task T3, sorry, task T1 and T2 and T4. T1, T2 and T4 doesn't have any dependency, so they start from the 0th week. So Actually 5 days makes 1 week, so they have taken in 5 weeks, so 5 days in a week. So you can see here number of days is 10 days, means 5 days equals to 1 week, means this takes 2 weeks, and 15 days means it takes 3 weeks. So T4 it is 10 days, it takes 2 weeks. So you can see here T1 it takes 2 weeks, and T2 it takes 3 weeks, and T4 it takes 3 weeks. So 2 weeks, and T3 can start his work only when T1 is complete its work. So T3 can start only when T1 completes its work. So T1 completes at 2 weeks, then only after 2 weeks only the T3 can start its work. So T3 can start its work once T1 is completed. So see, T1 is after T1 completion, that is second week, then only T3 starts its work. So milestone 1 completes its task in 3 weeks. And you can see the any other task or that is where waits for T3. So T3 it waits for T9. You can see here T9 can start its work only when T3 as well as T6 it completes its work. So T3 can complete in a 1 week. You can see here T6 can complete its work in 1 week, but since it depends on T3 also, T9 waits till T3 can complete it. So this is how the bar chart has been given. So once it is completed, it shows the finished task. Okay. So since this is in the 0th week, task T1, T2 and T4 starts and it ends in the and shows in the diamond shape. So T12 completes its work in 2 weeks. After that, the entire work is finished. So this is what the given a bar chart, or you can call it as a Gantt chart. So in this they are given on the staff allocation chart. You can see that these are the staff allocation, and this is the number of that is a week or a person that is in a overall involved in the project in a week wise. Okay, and you can see Jan is dependent on T1, T3, T9 and T10 and T12. He is a key role person for this entire task. And you can see the diagonal, wherever the diagonal it's not proper in this diagram, there is a diagonal shape. Okay, in the textbook you can see here T9 to T9 is a diagonal, means Jan will wherever in the diagram, if it is a diagonal, Jan come out completely involved in the task. He is a partially involved. Okay, you can see in the textbook also. Whenever you find a diagonal signal, means that particular task by this particular person will partially involved, not completely. The same way, Hali T1 and T8 is completely dependent on Hali. So is whereas Geeta that is a T2 is diagonally, whereas T6 and T10 is completely involved, whereas T2 is partially is involved by Geeta. So this is how, wherever you find a diagonal symbol, that particular person involved in that particular task partially, not completely involved in that particular task. So you can see it in the textbook clearly, but in the PPT won't not getting clearly. Okay. So next we see the estimation technique. In the estimation technique, that is organizations need to make software effort and cost estimate. Organization to make a software effort and cost estimates. There are two types of techniques that can be used to do this. That is cost estimation. One is experience based technique, another one is algorithmic cost modeling. So experience based technique is an estimate of the future effort requirement is based on the manager experience of the past projects and the application domain. Essentially, the manager makes an informed judgment of what the effort requirements are likely to be. Based on the experience technique, in the sense the manager of the project manager, based on his experience of the past project, he will give the software effort as well as cost estimation to the expert. And algorithmic cost modeling is an approach of a formulaic approach. That is, they have a set of formulas have been used in the algorithmic cost modeling to decide the project effort as well as cost estimation based on the product attributes such as size, process, characteristics, etc., as well as the overall experience staff involved. That is, experience-based approaches, experience-based techniques rely on judgment based on experiences of the past. Projects and the effort extended in these projects on software development activities. Typically, you identify the deliverables to be produced in a project and the different software components or the systems that are to be developed. You document this in a separate spreadsheet, estimate them individually, and compute totally effort required. So you have to, that is whatever the thing, there will be some based on this experience that there will be in a spreadsheet, Excel sheet, they will put and calculate overall involved and what is the cost of the project. It is usually helps to get a group of people involved in the effort estimation and to ask each member of the group to explain their estimate. So this is what experience-based approach. And in algorithmic cost modeling, cost is estimated as a mathematical function of the project and process attributes whose values are estimated by project manager. So they have given effort is equals to A into size of exponential of B into M. What is A? A is a organizational dependent constant. There will be some organizational constant value, like how for pi 3.14, the same way there will be organization constant. B reflects the disproportionate effort for the large project, and M is a multiplier reflecting product, process and people attributes. So M is dependent on process and people attributes, and effort, that is B, reflects the disappropriated effort of the large project. The most commonly used product attribute for the cost estimation is code size. So depending upon the code size also, the estimation will be calculated. Most models are similar, but they use as a different values for ABM. This ABM depends on the model. Estimation accuracy. The size of the software system can only be known accurately when it is finished. So several factors involved in the final sizes, use of the components, programming languages, distribution systems. As the development process progresses, then the size estimate becomes more accurate. Development process progress, then the size estimate becomes more accurate. The estimates of the factors contributing to B and M are subjectively vary according to the judgment of the estimators. And COCOMO II model and COCOMO II model also called as a constructive cost modeling 2. Constructive cost modeling 2 model also. An imperial model based on the project experiences. Well documented independent model which is not tied to a specific software vendor. Long history is it was published in 1981, COCOMO 81 through various that is instantiation to COCOMO II model. COCOMO II model takes into account different approaches to software development and reuse, etc. So COCOMO II is a constructive model, constructive cost model 2, and COCOMO II incorporates a range of submodels that produces a increasingly detailed software estimate. The submodels in COCOMO II are application composition model, early design model, reuse model, and post-architectural model. Application composition model, it is used when software is composed from the existing parts. When a software is composed, composed from existing parts. Okay, that is COCOMO II. One is application model, early design model, and reuse model. So in the early that is this model efforts required to develop the system and that are created from reusable components, scriptings, database programming, etc. So early design model is used when requirements are available but designs has not yet started. Used when requirements are available but design has not yet started. This model is during early stage of the system, design after the requirements have been established. The estimate is based on the standard estimation formula. That is, there will be some standard estimation formula will be used. Reuse model is used to compute the effort of reusable of the component from the existing software or from the existing application. Reusable model. Post architecture model is used once the system architecture has been designed and more information about the system is available. So this is the four sub-models of the COCOMO II models: application composition model, early design model, reuse model, post-architecture model. So in this you can see the COCOMO II model estimation model diagram. There is application composition model, early design model, reuse model, and post-architecture model. And very important question, based on this application composition model based on number of application points and number of function, that is based on early design model, and number of lines, that is reusable model, number of lines of source code, that is post architectural model. So number of application points based on the composition model, that is used for developing of the that is using dynamic languages, database programming language, etc. Early design model, that is based on number of functions points, initial effort estimation based on the requirements and design options, and the number of lines of the code reused is based on effort or to integrated reusable components or automatically generated code. And post architecture model is used for development effort based on the system design specification. So this is the COCOMO estimation model. Very important question and important diagram. Application composition model. This is application composition model. That is based on the formula that is supports the prototyping project and a project where there is a extensive reuse. Based on the standard estimation of developers productivity in application, take a case tools used into account. Formula is PM is equals to NAP into, this is into 1 minus modulo reuse divided by 100 in that is close the bracket prod. PM is a effort in person months, NAP is a number of application points, and prod is a productivity. And application point productivity, that is depending upon the developer's experience, capability, and IKS maturity and capability. Very low you will take prod 4, low you will take 7, normal and nominal 13, high 25, very high 50. So in the place of that is prod, you replace the particular numbers depending upon the point productivity. Early design model. In the early design model, estimates can made after the requirements have been agreed based on the standard formula for algorithmic models. And PM is equals to A into size of B into B, where M is equals to this ERS into that is this, where these are all into signature. Okay, A is equals to 2.94 is initial calibrate, size in K logs, B varies from 1.1 to 1.2.4. And what are the meaning of this is been given here. That is RCPX is a productive reliability and complexity, RUse is a reuse required, PDIF is a platform difficulty, and personal experiences, personal capabilities, required schedule, and the team support facilities. The reuse model takes into account a black box code that is reused without a change and code that has to be adopted to integrate it with new code. There are two versions, black box version and white box version. Black box reuse where code is not modified and effort estimated is computed. White box reuse where code is modified. A size estimate equivalent to the number of lines of new source code is computed. Then adjusts the size estimated for new code. use model estimate 1 for generated code. PM is equals to that is number of line code at that is into 80 by 100. This is something formula, not much needed. And reuse model estimated, this is also formula, and you can refer my notes, that will be helpful for you people. Okay, and yeah, we'll see this for this or all this you can refer my notes better, that is better. Yeah, project duration and staffing, as well as effort estimation, that is manager must estimate the calendar time required to complete the project when staffing will be required. Calendar time can be estimated using COCOMO II formula, and this is a formula, and there is dividend is equals to 3 into PM something. PM is effort computation, and B is the component that is computed as discussed, and time required is independent of the number of people working on the project. And staff required cannot be computed by diving the development time by the required schedule. The number of people working on a project varies depending on the phases. More people who work on the project, the more total effort is usually required. Very rapid build-up of people often correlate with schedule slippage. So by this we have completed the 5th module, first chapter. So please go through the videos. If you have any doubt, you can ask me in the online session. Thank you all.